Welcome to the start of our next unit. This unit is going to be focusing on statistics, and we are going to start today with the following targets. We're going to find the mean, median, mode, range, standard deviation, and outliers of a set of data values. And we're going to see what happens when we add a constant to a data set or multiply by a constant, and how that might change our measures of central tendency and dispersion, which are your mean or range, median mode, those are central tendency, and dispersion, that's range of standard deviation. So, in sections 1 and 2, we talked about earlier, central tendency and dispersion, that's our objectives. Central tendency, that's the middle of the data. Central, middle, that's kind of clue. Middle starts with an M, so does mean, median, and mode. So when we're thinking of central tendency or middle of the data, those are the three data statistics we're going to look for. Mean is the average. It's denoted by X bar. You can see it right here, X bar. X to the bar over it, that means average. Find the average manually, you add up all the values and divide by the number of items. You've done this before. Median is the middle number, and remember the middle number when the data is in order. So it doesn't matter whether it's the largest or smallest, largest, usually we go smallest to largest, but if it's in order, the middle number is the median. And the mode is the most frequently occurring value or values. Every data set will have a mean, every data set will have a median, not every data set will have a mode. If all values occur the same amount of times, then there is no mode. Two or more values occur the most and they are the same, then it's kind of like a tie, and all of them get to be the mode. But if there are no repeats, or they all repeat the same amount of times, then there can be no mode. So, example of the test scores. Okay, 72 plus 96, 67, 87, 87, 170, and 72. So I'm going to show you, we've all done mean, median, and mode by hand before. Real quick, I'm going to show you one more time, but we also are going to need a calculator for when we're in class. So I'm going to show you how to do it on the calculator as well. So we're going to put these numbers in order. 67, I'm just going to cross them out as I go. It's like 70, 72 occurs once, and then it occurs again. And then we have 87 occurring twice. And then we have 96, move this way, 96 and 100. So count, make sure that you have the same amount after you rearrange them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So appear to be accounted for them all. So the mean is adding them all up and dividing by how many you have. So I would do, you wouldn't need it in order for this, but since I already put them in order, I'm just going to use the ordered one. The mean doesn't matter what order it is, since you're adding them all up. So we're going to add those up, and then we would divide by 8 because there's 8 data values. So in your calculator, you either have to put it in as a fraction like this, or you have to add up the numerator first, then divide by 8. If you do that correctly, you're going to get 81.4. If you just hit divide by 8 at the end, what it does is it adds 67 to 96 together, then it adds 100 divided by 8. Okay, which obviously is going to be too much. So if your average, any of these, their central tendency, if they come up to be larger than your largest data value or smaller than your smallest data value, then you know you made a mistake. Okay? Median. The median is the middle number when you put them in order. 67, there's 8 data values, right? So if we count in 1, 2, 3, 4, 72, and 1, 2, 3, 4, and 87, there's 2 middle numbers. So when there's an even number, we take the 2 middle numbers, 72 and 87, add them up and divide by 2. So that is going to be, well, the halfway point between those would be 79.5. The mode is the number or numbers that occur most often. We can see the 2 numbers that repeat are 72 and 87, so we have 2 modes, 72 and 87. Okay? So that's doing it by hand. I said you need a calculator today. Well, if we have a calculator, what we can do is if we hit the Stat button and Edit button, and we're going to write this down, Stat, Edit, Stat button, and Edit. Okay, Stat, Edit, and then we're going to go to List 1. Now let's say I had numbers in here. I'm just going to put random numbers in. And I want to delete every one. I can go up to the top of List 1, and if I hit the Clear button and Enter, it deletes them all for me. Okay, do not hit Delete. If you hit Delete, it will erase the list, and then we have to go to Memory Archive and bring it back. It can be done, but it's easier if you don't. Okay, so we just hit Clear at the top of the list to delete them. Okay, so we are going to enter in our data values. The cool thing is they don't have to be in order. I'm going to prove it to you. I'm going to put the unordered data values back in. So I'm going to put in 72, 86, 96, and we had 67, and then we had 87, and then we had 87, and then we had 100. And then we had 70, and then we had 72. So we put our data values in. Notice 8, L1, 8, that's the 8 input is 72. Remember we had 8 inputs overall. We enter one more time, it's waiting for a 9th input. We don't have a 9th input. But always count and make sure you have the same amount of inputs and that the inputs are the same as you had previously. Okay, so after that we're going to hit second quit. So we're going to go hit, we're going to Stat, Edit. We're going to put L1, Clear, and then Enter, right? And then we enter data values. And then we hit Stat, enter data values, and then we hit second and quit. Okay, so then we're going to do that. We're going to hit second and quit. We're back to the main screen. We're going to hit Stat again and Calc. So we're going to do Stat. And we're going to do this time, instead of Edit, we're going to go over to the Calc menu. So over on the Calc menu, there's lots of different things to choose from. We're going to use a lot of these different ones eventually, these different ways to regression techniques to get different equations. We're going to pick one bar stats, or number 1. It's the very first one. I'm going to go to 1 bar stats, or number 1 on the list. Okay, if we go to 1 bar stats and we hit Enter, we get all of our values. Okay, we got lots of things. So let's slide this out so we can have this on our screen here. We'll go back and take a look. If you look, it gives us X bar. X bar, that's the mean. 81.375. Remember I told you, and you guys did a calculator, 81.4. I just rounded it differently. This is the sum of all the numbers. We don't need it. This is the sum of all the numbers squared. That's what that summation notation means. You probably see me wear my mathlete shirt in one. One we haven't talked about yet, this is going to be our standard deviation. We haven't talked about that yet. N is the number of data values. It's always a good thing to check in case you accidentally didn't put all of them in. If I go back here, here's some values that we might like. Min, median, max. You're going to need your min and your max for the range. So I'm going to slide this out here. So those are some other values we have, but it gives us our median, which is 79.5. The only one it will not give us on the calculator is the mode. So you have to do the mode by hand. But this basically allows you to just put the numbers in there, especially if it's a large data set and you don't want to have to reorder it. You can just put all the values in one time in a calculator, and it will give you everything, including standard deviation, which is very time-consuming to calculate by hand. So here is the same data set that we had previously. Okay? So as you can see on the previous slide, they give you a way to calculate the range. If you need to know the maximum and the minimum value. On this down here on the bottom, you can see they give you the max and the min. So that's kind of helpful if you can't figure out which ones are the max and the min. But usually we can look at a data set and pick those out, I would hope. 100 minus 67 is 33. But if it's hard, the data values are decimals, it's hard to see which is the max and which is the min, that could be a way to help you out. So the range, this is a dispersion now because it says how spread out is the data. What's the difference between the largest and the smallest value? That's the range. Standard deviation, that's the sigma. See the symbol right here, the sigma? Looks like an O with a hat bill sticking out. Okay, well, what this formula is you take each of the x values, subtract the average from them, square them, add all of them together after you square those differences, and divide by the number of data values there. So if we were going to set this up, it would look something like this. 72 minus 81.4 squared plus 96 minus 81.4 squared. And we would keep doing that and fill in all these values, and we would only have 8 this time. It's not even that many. We'd fill in all the values all the way down the list like this, and we would find all those differences, square them, divide it by 8 in this case, because that's our number of values, and then square root it. I don't know about you, but I think that we all have better things to do with our time than to plug this in and do it by hand. There is a way you can do it. And if you don't have a calculator like the one we have in class at home, and you're making up an assignment or you're absent, you will have to do it this way by hand. Okay, but on our calculator, we can use the standard deviation, and that is this. Standard deviation is right here. The standard deviation of x. So the standard deviation for this problem is 11.92 approximately. And that means on average, okay, how spread out are your data values, from each other. Okay, so this is not the overall average, it's like how spread out are the data values from each other. The bigger standard deviation means that's how your data values really are way far apart from one another. A small standard deviation means that the data values are closer together to one another. Okay, so that's what standard deviation means. The bigger the standard deviation, the more spread out the data values are from each other and from the mean. So the bigger they are, the smaller they are, the closer they are to the mean and to each other. So it all depends on what you're looking at. So it may be good if the data values are closer together and closer to the mean or the average. It may be good if they're spread out. For instance, like a test scores, if you have an 85% test average for one class, but the standard deviation is really high, that means that really you had like a couple people at the top that was really big scores, but everybody else was kind of all over the place. Whereas if you had a high average or mean, but the standard deviation is small, that means that a lot more people did pretty well on the test. Okay, so what if there was an outlier in our set? Okay, so let's just record some stuff without the outlier. What's happening? Okay, so we had a mean, we had a median, we had a mode, we had a range, and we had a standard deviation. Okay, or that was symbol right there. We call that sigma. Excuse me. Lowercase sigma, anyways. So our mean without the outlier was 81.4, 79.5 for the median. The mode was 72 and 87. And our range was 33, right? 100 minus 67. And our standard deviation was 11.92. So let's include the outlier. And I'm not going to do this by hand. I have a calculator. I'm going to go back to my graphing calculator. If I'm going to put 25, so we bound the last test in the study for, let's say, got a 25 on it. So I'm going to go back through my steps, and I'm going to hit Stat. I'm going to go to Edit, and I'm just going to go, doesn't matter where I put it, I'm going to put number 9 at the bottom of our list, or at the 9th spot. We're going to put a 25. So now we have a 9th data value. Now we're going to get out of here. We're going to hit second mode or second quit. We're going to go Stat. Stat. We're going to go to Calc, 1 bar stats, and let's see what our new values are. Okay, well we can see that our new X bar, our new average is 75.1. Okay, we can see from this screen, I'm going to go with what we can get on here. Our standard deviation, we'll round that up, that's about 21. Okay, and we can see, let's see, what else do we have? We have 9 data values now, obviously. We can do our range and our median. Our median is 72. Our median is 72. And our range is now, well, min is 25, so 100 minus 25, which is 75. The only thing left is our, let's get these out of the way. The only thing left is our mode. Has our mode changed though by putting 25 in? Our mode has not changed. It's the same. It's still the same. It's still 72 and 87. Now, if we'd have added a 72 or 87, that would have changed our mode. Or if we'd have added another number that repeated. But since we put another number in that repeated, it stayed the same. So by putting an outlier in there, and in this case our outlier was way below all the other values, it lowered our average, it lowered our median, our mode stayed the same. Our range got larger, and if this range and standard deviation, even if we'd gone way above the other ones, that would have gotten larger as well, because now you've spread the data out further. So outliers, they seem to affect our measures of spread a little bit more than our central tendency values. Right? You can see that essentially, although it did lower all except for the mode, it really put a stretch on our range and standard deviation. Okay, let's see what happens when we add, this is mostly section 11.2 here. If we add 5 to all the data values, and then what if we multiply all the data values by a constant of 2? What happens to our average? What happens to our other central tendency values and our dispersion values? If we add 5, I'm just going to cut to the case. We can go through and show you. Here's what happens. Our new average for our data set, it was 81.4. If we add 5 to all the data values, this is what happens to the mean, median, and mode. These all went up by 5. If we look at our standard deviation and we look at our range will stay the same, and our standard deviation will stay the same. And if you think about it, they stay the same. That makes sense, because if we add 5 to every data value, they still stay the same, spread out from each other, and same spread out distance from the average, even though the average changes. So adding a constant will not affect the standard deviation or the range, the dispersion values, but it will affect mean, median, and mode. It will make it go up if it's a positive number you add, or it will decrease if it's a smaller value. What if we multiply by a constant? Well, our new mean will be 162.75. Our new median will be 159. Our new mode will be 144. And 174, we're comparing to our old values. Our standard deviation in range, our range will be 66. Our standard deviation will be 23.83 approximately. And we can see that these all got multiplied by 2. So what's the generalization we can get from here? If you multiply a data set by a constant, then all the dispersion values and all the central tendency values will be multiplied by that same amount compared to the original. So I think we hit all of our targets pretty well. A little bit longer today, but we had a couple lessons we put together. So be ready. So be ready for the notes to be presented in class tomorrow. Have a good day.